Here's your packet lesson, 3-3, day 1. Starts on page 95. So if you watch the pre-lesson, which I hope you're getting in the habit of doing, we discussed these formulas. And again, you're just going to figure out for parts A, B, C, and D. It's a warm-up. They're saying simplify. In other words, go on the hunt and figure out which one this equals. Well, if I look at 1 minus 2 sine squared x, I see it right here. Nothing else even comes close to matching it. So this is asking me to go that way. In other words, I'm going to replace it with this, which means it's going to equal cosine. But look at this little hint. It says double whatever the angle is. Well, in this case, the angle is x. It's just a variable, so I'm going to double it. It's that easy. You just let it be that easy. Now, this problem, honestly, is the exact same problem as this, but you have a different angle. So we would say, all right, let's match this up somewhere. Well, that doesn't match this. This doesn't match this. It does match this. So if I go that way, it's telling me replace this messy looking thing with cosine, but double whatever the angle was. In this case, the angle was 2x. So I'm going to double that and make it 4x. So you're just manipulating the formula a little bit. Now we got cosine squared, sine squared. See how I'm ignoring this and I'm ignoring that right now? I'm going to go on the hunt for that. Well, it's right here, which is telling me to go that way. So I'm going to go cosine, and now this tells me what to do with the angle. Just double it. That's it. Okay? So a lot of you are like, well, what does this even mean? Well, nothing. You're just manipulating the equations. You're working with it. You're getting introduced to it. The real meat and taters is coming down here. We're actually going to have to solve something. So letter D. Obviously, this connects with this, which means I got to go from this looking thing to that looking thing, which means all of this is going to equal tangent of whatever the angle is doubled. Well, notice the angle is given to me here, but it's also given to me here. I just have to double that. So it's going to be 2 pi over 3. And again, understand the instructions. It just says simplify. It doesn't say solve or find the exact value, because we could find the exact value of this one, because we know this is 2 times 60, which is 120. We could flip the spinner and find tangent. This one we couldn't, this one we couldn't, this one we couldn't, because we don't even know what the degree measures are. They're just representations. Okay, now let's tackle this. Please take a minute and watch the pre-lesson if you haven't done it. But that right there, we're going to replace it with the only thing we can, and that's this right here. So we're going to say, all right, we're going to take that out. We're going to go 2 sine of u, cosine u. We're going to stick with u, so I'm going to replace that with a u. Sine of u equals 0. This is algebra. Notice we have a sine here and a sine here. We're going to factor those out, and we're going to write in parentheses whatever we have left. This is just basic factoring 101. And now you recall seeing these before. Now you have 2 situations to solve. If this times this equals 0, then either sine of u has to equal 0, or 2 cosine u plus 1 has to equal 0. And we got to solve both of them. Hopefully you're getting better at these, where you're like, wait a minute, I know what sine is. It's opposite over hypotenuse, so the opposite has to be 0. And that would only happen at 0 degrees, but it would also happen at 180, or 0 and pi if you want to get fancy. This one, subtract 1, subtract 1. 2 cosine of u equals -1, divide by 2, divide by 2. I'd get cosine of u equals -1/2. And here's where your general understanding of special right triangles needs to kick in. There's only one kind of triangle where one side is exactly half the other, and that's a 30, 60, 90. But my adjacent side needs to be the -1. My hypotenuse needs to be the 2. Notice it's saying find all solutions. That's a huge hint. So you're not done just because you find one. There might be more. And this says all of your answers can be between 0 and 360. You can include 0, but don't include 360. That's what the parentheses means. Don't include 360. The bracket means include 0. Because 0 and 360 are just the same thing. So that's saying you can spin your spinner one revolution on the hunt for where this is true. Well, first of all, my adjacent side needs to be negative. So if I drew a triangle over here or over here, see my adjacent side's positive? So I can get rid of those quadrants. I know my adjacent side needs to be a 1, negative 1 actually, and my spinner needs to be twice that, which means this side needs to be my square root of 3, and which means this is 60, which means I spun my spinner 120 to get to that situation where this is true. But then the other place it can happen is right here, where my spinner's 2, my adjacent side's negative 1 still, and this would be negative square root of 3, but I don't really care about that. It just helps me understand that this little sliver is also 60, that's my reference angle, which means I'd have to spin my spinner 180 plus 60, which would be 240. So there's 2 of my answers, and there's 2 of my answers. Okay, let's go on to this next one. Again, I hope you watched the pre-lesson. I have a decision to make. What am I going to replace this with? Well, I have 3 choices. Remember in the pre-lesson I said you want to kind of steer away from that for this section? Because whatever you replace this with, it needs to match this. And that would be this right here because it doesn't have sign involved. If you pick that one, it'd be a real nightmare. This one turns into a trinomial. 2 cosine squared u minus 1 equals cosine of u. And so now I remember my trinomial rules. I have to set everything to 0. And so I'm going to subtract cosine of u, subtract cosine of u. None of these are like terms. These cancel. So just to make it look like a trinomial, I'm going to go like this. And here's where your brain needs to lock into where you're comfortable. This is the same thing as 2x squared minus x minus 1. And if I factored this, I'd say, hey, this has to be 2x and x. This is a negative 1, so I know this is a 1 and that's a 1, but now I have a decision to make. I'm going to put a negative here or a negative here. Well, I need one more negative than I have positive, so I have to put the negative here and the positive here. Because if I FOIL this, negative 2x, positive x will give me my negative x back. That tells me what to do up here. Thinking of it just like this, I'm going to go 2 cosine u, and I know that negative 1, so there's a 1 there and a 1 there. I need one more negative than I do have positives, so the negative's got to go there, positive's got to go there. And now I got to solve. 2 cosine u plus 1 is 0, or cosine of u minus 1 equals 0. This one I'm going to start with first. So I get 2 cosine u equals negative 1. Divide by 2, and I get negative 1/2. Now, if you notice, we already did that problem. So we're going to steal those 2 answers. So I know it's 120, and I know it's 240. This is new. Add 1 to both sides, and I get a 1. Where could the adjacent and the hypotenuse be not only equal, but my adjacent is positive? Well, if I start at 0 degrees, something pretty cool happens. Look, this is my adjacent side, this is my hypotenuse. They're both equal and they're both positive. So there's one of my answers, 0 degrees. Now, if I went to the opposite side and you thought about it, that's where your adjacent side's negative and your hypotenuse is positive. So if you said 180, you'd be wrong because cosine would be negative 1 over here. So that's not what we want. We only want where it's positive. If I checked out 90, my adjacent side disappears. If I checked out 270, my adjacent side disappears. So that's the only place where cosine equals 1. All right, so now look at this guy. I got cosine double angle, which means replace it with this, this, or this. We know not to use this. This is telling us which one to grab. It's going to be this one. So I'm going to take this out, and I'm going to go 1 minus 2 sine, I'll use x's this time. Sine, that's actually squared, equals sine of x. Now again, I'm going to subtract sine of x, subtract sine of x. I want this thing to look like a trinomial, so I'm going to put my squared term first. Sine squared x minus sine of x plus 1 equals 0. Now, I don't know about you, but trinomials are hard enough. So I'm going to multiply this all by a -1. So I'm going to change all those signs, and that's going to make factoring way easier. So now I got 2, think of this as x squared, but it's sine squared. So 2 sine of x, sine of x. This time I have a -1, so I know these are going to be 1s, but I want one more positive than I have negatives, which means I need to attach the 2 to the positive 1, and then this would be negative. And if you FOIL this out, you'll get this back. So now I got to find where 2 sine of x minus 1 equals 0, and I need to find where sine of x plus 1 equals 0. I'm going to add 1 to both sides, divide by 2, so I get sine of x equals 1/2, and I'm going to go on the hunt. Well, hopefully you're getting better at this. So where could this possibly happen? Well, 30 degrees would give me my 1 here, my 2 here, my square root of 3. So 30 degrees is one spot where it happens, so I'm going to write that over to the side. But it also happens over here, 1, square root of 3 negative, and 2. Remember, this is my 30-degree reference angle. I'm not going to put that down as my answer again. I have to figure out where did I have to spin my spinner to create this drawing. So it'd be 150 degrees. And the last thing I need to do is figure out this one. So I'm going to subtract 1. Sine of some degree measure equals -1. Remember what sine is. It's opposite over hypotenuse. Now because I'm running out of recording time, I'm going to cut right to the chase. I know where this happens. You see, that's where the opposite side disappears, and that's where it disappears. 90, yeah, these opposite and hypotenuse are the same, but I need the opposite to be negative, and that only happens down here at 270 degrees. So there's an answer, and there's my other 2. So I have a total of 3 answers. Okay, that'll do it. Good luck on your homework.